Hey guys, it's Vince. Today in this video we are continuing with volume number 18, and this one is a CNC plasma controller built incorrectly, and once again many of you have to see this to see the pattern being created over and over again, and that's why I tell all of you, especially if you're new to the channel, watch my series from the beginning, and I'm talking about my fail video series, because you're going to really witness a pattern develop. YouTube content creators typically mimic what they see other content creators do. And that's something we've seen all over social media. This genre is no different. And when we jump into this, you're definitely going to see a pattern, especially as you go through 3 or 4 of my videos from the fail series. You'll see exactly the pattern that they typically follow. So let's jump right in.
Design started with these aluminum extrusions I found at the dump. These are 45 by 45 and 45 by 90 millimeter Bosch Rexroth extrusion. I don't know what they had been used for previously. I used to work for Bosch, and we used this system for building assembly lines in a factory that produced automotive components. But they're very nice extrusions. They're quite expensive.
Okay, this is a very unique situation. Let's think about how unique it is. I've been in production robotics online now for well over a decade, and I can tell you, in dealing with large and small machines and tons of different individuals, I've never had someone say, let alone a content creator, that they found aluminum extrusion at a dump in virtually pristine condition, which he didn't technically say, but we know that it would have to be in pristine condition in order for him to formulate a production robot chassis out of, or else naturally any bends or warps would translate into inaccuracies when machining. That and the fact that aluminum extrusion, aluminum in general, carries scrap pricing. So that means that no one cashed this aluminum extrusion out. This guy is very lucky. Let's see where this goes.
And when I found them at the dump, I knew I was going to be able to use them for something. And the particular design that I've used for this CNC plasma cutter with this cantilever bar is particularly well suited for these kind of components. The Y and Z axes hang in free air over the table.
I'm sure many of you already realize that in previous volumes, I've discussed this CNC chassis here, which once again was a plasma chassis. And it's interesting to note they are remarkably similar to the video we're watching now of this content creator. And I'm pointing this out for a couple reasons. First and foremost, you have to wonder how many of these content creators are feeding off of one another, meaning naturally they see something being done, they then formulate content themselves, replicating what they've saw to the best of their ability. And what's really interesting is the original content creator who did this actual video on this CNC plasma construction was selling plans for the unit. Makes you wonder, right?
There's nothing on either side, so you can put quite a large sheet, a sheet that's significantly larger than the table. The laptop mount is removable, so if you had a very large sheet, you could take that off. I cut some brackets out of 1/4-inch steel.
Hey guys, we can see here he's using a pulley transmission. I get a lot of different questions regarding pulleys. And the thing to keep in mind is that under best practice, when you're dealing with a subtractive manufacturing robot, a robot that simply cuts, creates debris, these are not the best transmissions to use. Now, why is that? Of course, you're going to have more debris that can naturally get on your pinion, get within your teeth. The belts over time will stretch. This is inevitable. If you don't catch it in time using proper routine maintenance, and that's variable on any robot, you will find that your tolerances will shift. Again, a plasma robot does not have any of the typical torque requirements that we see on a router or mill, but that does not mean that, once again, they are not susceptible to problems using these transmissions. So please be aware of that. If you are contemplating using a pulley system, be aware that using direct drive, dealing with a ball screw transmission, and even a rack and pinion is going to give you much better results. And realistically, when you factor in the belts and you factor in dealing with pulleys, it's not that much of a difference in price as it used to be. So keep that in mind. And once again, just to clarify, subtractive manufacturing means that the robot is cutting or removing material. Additive manufacturing is 3D printing, where we're adding material to create what we want to, once again, formulate into a product or a design.
Hold the 45 by 90 extrusion on the back of the cart, and then I milled these half-inch aluminum plates. Half-inch is probably overkill, but it is the size that I had, and they hold a pair of beveled wheels that fit into this groove in the extrusion.
Okay guys, once again we have wheels being used on the linear axis of the robot, and we see this being done constantly, so much so last week's chassis had nylon wheels. It was a router. Now we have a plasma system and it's using wheels. What's really interesting though is this content creator wants us to believe that he found this extrusion at the dump, and once again it's in pristine condition, so much so that even the track system that's running the wheel has no burrs, is perfectly straight, and not causing any symmetry issues when these wheels rotate to cause friction and once again deviate the accuracy of the linear axis. I don't know if that's true. What I will say is this, and I get asked about this a lot: when at all possible, alleviate wheels being used. And the main reason that is with a mill or a router, and I've discussed this in my previous video, you're dealing with debris. Any type of debris that gets inside that track, in this case, or not a track, is going to cause friction on these wheels and once again give you issues with motion linearity. The other thing is that if we're dealing with a robot like a plasma system that really doesn't see a lot of debris, we are dealing with a lot of moisture. And that moisture, especially on a metal wheel, if this is a steel wheel, which he did not specify yet, that can easily generate rust. Rust will deviate the surface finish and cause friction, especially when it's rotating inside of a track. And once again, we're getting back to that linearity issue as far as friction will deviate the accuracy of the linear axis. Now, whether or not you decide to use this, that's totally up to you. The only systems that could even tolerate using wheels would be something similar to what you'd see with a 3D printer, where once again, additive manufacturing, where we're using it in a very, very, very light form of motion, where there's no friction, there's no debris. Dust can throw certain things off. It's very uncommon that that would actually ever do it. But in a shop environment, under a general production robot where we're dealing with, cutting and steel and moisture and water, these are not the best suitable transmissions. I cannot emphasize that enough. They're being used all over the place. I've seen guys use ball bearings as the wheels, and just think of that. Ball bearings are steel, guys. And I know that they're extremely durable, but they're also extremely susceptible to rust. So thinking about that, generalizing the application you're working with, that will tell you in general what makes the most sense. Staying with tried and true real transmissions, rack and pinion for a plasma system is the most general transmission. Ball screw would be the next step up if you want ultra precision and again, virtually a maintenance-free transmission. These will cost more, but they'll pay you back in knowing that you have a reliable system.
And then there's a simple bearing. These are skate bearings that ride on the flat portion in the front.
It's super interesting, after discussing the use of bearings, that this individual is using skate bearings, which are just ordinary ball bearings, to replace a proper linear bearing. And guys, I want to point out, because many of you already know where I'm going with this, you can see the plasma water table is literally inches from this linear bearing that he's mounted on the inside of his y-axis. So what do we think is going to happen when a part falls into that water table, which, for my guys not familiar with plasma system robots, what happens is when the cutter is done cutting parts out, it drops the part, typically, if it's small enough to fit in between those grates, into the water cooling the part. The issue is, every time that happens, the effect from it falling into the water is the fact that it splashes all of your componentry around it. So guess what happens to that bearing when the part is close to it? Exactly. So we're just accelerating surface rust. Once again, it proves my point. You better be careful of who you're watching as far as content creators, because let's not forget most of the videos on YouTube or social media in general are done based around an entertainment principle. It's not done directly around the DIY guy who's trying to AKA do things correctly. Huge difference. Once again, major engineering flaw. Okay guys, let's discuss a question that comes up at least 4 to 6 times a week by potential clients looking to purchase plasma CNC robots. And that is, Vin, is there a way I can just look at the chassis and tell by looking at the chassis there's a direct red flag that tells me the vendor does not understand the electronics used to support this production robot? And there is. If you look in this picture and we see this switch here, now of course the content creator in this video never discusses any detail about the switch, for whatever reason. The fact of the matter is, if a vendor selling a plasma CNC robot does not offer in the description of the robot that they're using IP67 switches, and they only state they're using switches, that means that the switches are not rated for waterproof use. And most of these vendors are always very quick to show you that they incorporate water tables with the plasma robot. Well, guess what happens when you're not using a waterproof rated switch? Again, guys, the whole reason you would pay a professional like myself is to make sure that the details are covered. That's what true engineering is. That's what I feel leads up to the best engineering, is that all details have been covered. And when you say that that's a minor detail, I beg to differ. I think many of you would agree with me that's a major detail. Yet when we look at vendor descriptions, you typically never see IP67 rated switches. On top of the fact they don't even know what you're talking about. I would highly recommend you message someone if you're looking at purchasing one of their robots, and if they're including switches, which 99% of them all do, think in terms of what that would do to your robot if that switch is protecting it or if it's producing homing features. I mean, you are really playing with fire. And I cannot emphasize enough how many of these details sabotage guys. And right now I'm putting a snapshot from my store of the Zippy IP67 rated switches I carry, and I believe I'm one of the only vendors that I've ever seen actually carry these. And I'm proud of that, because when guys ask me, hey, I'm building a plasma system, what do I need? Or I want to install switches. Well, then we already know these are the switches to use. Also, my guys out there running mist coolers, these are imperative for your system as well. We want to keep moisture out of critical components as much as possible, and we have to think ahead. It's the engineering we do prior that will execute that perfect product that you're looking for in the end. So keep that all in mind.
And that's what supports the y-axis. The z-axis is the slide from a 19-inch Dell monitor. Basically, this part moves up and down, this part is stationary.
It's really interesting when we think about the titles used by content creators on their videos to generate hits. I mean, it's like the ultimate bait and switch technique. We always see things like, hey, I built my CNC plasma robot for $5 and parts I found around the house, when what they're really doing, and hopefully social media will catch up in the sense that when people post incorrect information that affect their audience negatively, other than them generating excess clicks, which are fictitious clicks anyways, because the people that are watching this information, hopefully to gain some sort of knowledge to replicate what they're seeing, that it would actually deter them from getting those clicks. So we stop the misinformation, at least from an engineering perspective that I see. I think many of you feel the same way. Again, I am not going to say at all that paying for my services is cheap. I'm not here to be cheap. I'm here to be accurate. And the idea is that the people I support, they get the results they're looking for. I think this gentleman could have made a video directly correlating to, hey, I generated automation with a stepper motor and a Dell monitor slide. Check this out. It's a really cool experiment. And he could have made that super interesting and got as many views as actually misleading people with an outrageous title, just to once again gain some sort of popularity, spreading misinformation on social media.
Threaded rod. Pretty straightforward, and about as simple as I could make it. Our controller box is in this Lawn Master sprinkler controller box, and it is attached to the back of the y-axis, and it moves along with the y-axis. Inside here, we've got a Mach 3 USB controller card. And that's hooked up to 3 of these inexpensive stepper motor controllers.
This is by far and away one of the worst demonstrations of a CNC controller I've ever featured in any of my CNC fail videos. And that says a lot, guys. I cannot emphasize what you are looking at with the patterns these content creators do. They all feature affiliate links for products they really don't understand, in which case he's using a USB motion controller board, which USB in itself, working with CNC in general, let alone a plasma system, is completely unstable. I'll put the email up here from Balzis at CNC Drive, lead engineer who manufactured the UC100 USB motion controller. You can read directly from them what they experience with their own controller. I'm not saying this. And what do you think is going to happen in a plastic electronics enclosure which cannot be grounded, on top of the fact nothing here is shielded, there's no ferrites used, there's absolutely nothing done here to mitigate EMI, and he's working with a plasma CNC robot. Guys, you are doomed to failure. Yet, he's such a nice guy, he decides to post the affiliate link so everyone in his audience can purchase the same components he's using to create this contraption here. So I want you guys to think about what you're seeing, and for those who think I'm too harsh, let me ask you a general question, and this is interesting. I really would love to hear this in the comments. How many of you would think I'm too harsh on him if you ended up buying some of these components and then you ended up finding out your system is unstable? Would you hold this guy accountable? Let me ask you a better question. Could you hold him accountable? I mean, he's just spreading misinformation. You listen to it. Are you okay with that? I really want you to think about what I'm telling you, because it's frightening how many potential clients come to me. Usually they come with me with fear because they've been burned before by guys like this that are selling components, or vendors that are selling components like this. And then all of a sudden they are amazed how when they purchase something correctly, oh wow, it works. It just works. I don't have problems. That's what we're looking for, guys. I really, really want you to think before you type. If you're going to ask a question, please do. If you're going to leave a comment, please do. But think about these poor people who may or may not do as much due diligence as you do, and all of a sudden they get burned because affiliate links like this are popped up by guys demonstrating what they feel is genuine information, and it isn't.
I believe these cards are about $40 on eBay. And these controllers, I think they were about, I want to say they're $23 each. They were quite inexpensive.
I'm sure you guys who have been following my channel for some time, watching these CNC fail videos, realizes the pattern. And I've discussed this with all the people that are stumbling on my channel, and more are. Check out the past videos. You will recognize a pattern with all these content creators in that they love discussing the price of the components they use. The cheaper it is, the better it is. The more enticing it is for their audience. You've got to click on it. In their minds, they realize that the human psyche is driven by the fact that if it's cheaper, I've got to click on it. I've got nothing to lose because, of course, this guy's using it and it worked for him, so I'm going to buy it and I'll replicate exactly what I'm seeing. Unfortunately, we all know, or should know after watching videos in these series, the patterns that these guys reproduce are amazing, right down to the components. I want you guys to go back and look at all my CNC fail videos and look at the USB boards being used. This board right here that he's highlighting in this system has been used in multitudes of systems in the past CNC fail videos. They copy one another. They replicate the same information that they're hearing other content creators talk about or people in forums, and they just disperse it amongst themselves. Unfortunately, it hits a lot of innocent people. But the pattern is something we all must follow, and they always discuss prices because they know if they can make it sound obscenely cheap, you are going to be more interested.
and then there's just some terminal strips in.
And it just gets worse from there, guys. Looking in the remaining portion of the controller, we can see that he's got a terminal splitter, not much else other than a bunch of spaghetti wiring. There's no ground bus. There's no double shielded cables being used. There's no discussion of him talking about EMI, what he's done to mitigate EMI. Nothing. This is simply left for his audience to have content and for them to decide. And we see this more and more, as I said, with the pattern of content creators. If you're serious about building a CNC plasma robot, I highly recommend you review some of my previous videos covering controller builds, and you can see using resources like Lincoln Electric. I've got the PDF manual direct from their engineers. You can read what the pros do to see exactly what kind of technology goes into these robots and what must be done with the components as far as supporting them to make sure you're not building a paperweight. Okay, guys, that wraps up another volume in the series. And once again, I want to thank everyone for their support. The channel is growing immensely. And I cannot emphasize enough to my novice guys, anyone looking to get involved in CNC robotics, be it plasma, mill, router, whatever it may be, take your time. Make sure that you do your due diligence, do your research, and hire real professionals if you need help. Relying on content creators, if you guys just review my CNC fail video series, just review a couple of them. You're going to see the pattern. I've discussed that in a video, and this pattern carries over, guys. Unfortunately, it's a double-edged sword. We're seeing this technology expand greatly. Automation is now virtually everywhere from vacuums to lawnmowers, and in the next 5 years, my prediction, it's going to extrapolate even greater, probably 10 times what we're seeing now. That being said, there's, of course, a lot of opportunity, and the people that are looking at this opportunity aren't always genuine in the knowledge that they possess. So please be careful. Thank you again. Take care.